Hello everyone, welcome to my YouTube channel The Luminous Science. Today we are going to see about the heterocyclic compounds. Definition: heterocyclic compounds are the cyclic compound that contain at least one atom which is other than carbon within their ring structure. So as the definition itself suggests or explains, heterocyclic compounds, hetero which is nothing but different, in a cyclic compound. So in a cyclic compound of carbon atom, if one of the carbon atom is replaced by any other atoms like sulfur, oxygen, nitrogen, usually are termed as heterocyclic compound. The key characteristics of heterocyclic compounds are the non-carbon atom or atoms are embedded directly into the ring, that is the heteroatom or the non-carbon atom which is present in the ring are directly embedded or placed inside the ring of the carbon compound. The ring size can range from 3-membered ring up to large macrocycles, though the 5 and 6-membered rings are the most common and stable. The ring size may last from 3-membered or up to a large macrocycle, but usually the 5 and 6-membered rings are considered as they are more stable in nature. These are or can be saturated, partially unsaturated, or also aromatic in nature. These characteristics will be studied deeply in further sessions and videos when we take example of individual hetero compounds. What are the importance of heterocyclic compounds? So, the biological importance: DNA and RNA bases are heterocyclic system. So are very much essential vitamins like B complex vitamins and amino acid like proline and tryptophan. Next importance is in pharmaceuticals. The vast majority of modern medicine such as aspirin and penicillin contains at least one heterocyclic ring. The heteroatoms allows these molecules to mimic the biological structures and bind efficiently to receptors in the body. Since heterocyclic compound, some of the heterocyclic compound which can mimic the properties of biological molecules helps in biological function more efficiently when the actual biomolecules fails to do so. The next one is material science. They are used in making dyes, plastic and organic light emitting diodes which are also called as OLEDs. Those were the importance of heterocyclic compound, and in this session we are going to deal with the synthesis and reactions of some heterocyclic compounds such as furan, thiophene, pyrrole, pyridine, indole, quinine and pyrazole. So now let us start with synthesis of furan. Furan can be synthesized by many methods and we are taking the method of from pentasone. Furan is synthesized from the fumarole which is obtained by the acid hydrolysis of pentose sugar. Now we'll consider a pentose sugar which undergoes hydrolysis to form a furan. So which on treatment with concentrated acid and heat which loses 3 molecules of water and forms the corresponding aldehyde. So when this corresponding aldehyde of furan is treated with zinc oxide or chromium trioxide in presence of heat, removal of carbon monoxide will take place, leading to the formation of furan. So the synthesis of furan here we are seeing is from the pentasone. So here pentose sugar is taken which on hydrolysis, especially acid hydrolysis, we are considering a proton. Thus it is also called as acid hydrolysis will give us furan. So, which on heating with an acid, removal of 3 water molecule will take place which leads to formation of corresponding aldehyde. So, when this aldehyde is treated with a zinc oxide or chromium trioxide in heat, removal of carbon monoxide takes place leading to the formation of furan. Now we'll see some reactions of furan. The first one is nitration. Nitration of furan is achieved by reacting furan with nitric acid in acid in nitric acid in acetic anhydride resulted acetal nitrate in which nitrogen dioxide act as an electrophile. So this is a two-step reaction. So in the first step, we'll consider nitric acid, which will react with acetic anhydride to give acetyl nitrate. So this acetyl nitrate will react with the furan to give 2-nitrofuran. So here nitration is nothing but addition of nitrogen to the given compound. So for furan, it can be achieved by the following reaction as thought earlier. The next type of reaction we are going to see is acylation, which is also called as Federal-Kraft acylation. So the reaction of furan with acetic anhydride in presence of BF3 will give us 2-acetylfuran. So here 2-furan, which is treated with acetic anhydride in presence of BF3, will yield us 2-acetylfuran. And the next compound we are going to synthesize is the thiophene synthesis. So the synthesis of thiophene can be achieved from sodium succinate. When sodium succinate is made to react with the diphosphorus trisulfide in presence of heat, we'll get thiophene. The reaction is as follows. And some of the reactions of thiophenes are sulfonation. When thiophene is heated with cold concentrated sulfuric acid, the thiophene to sulfonic acid is obtained. That is, this is the reaction which represents sulfonation. When thiophene in cold condition is reacted with concentrated sulfuric acid, we'll get the corresponding product, that is a thiophene to sulfonic acid. Next one is chlorination. When thiophene reacts with halogen like chlorine or bromine to give 2,5-dihalothiophene. That is, when thiophene reacts with chlorine gas in presence of dioxane, it yields us 2,5-dichlorothiophene. So these are some reactions of thiophene which you need to remember, which will be asked for 2 marks in your board examinations or in your semester examinations. The next compound or heterocyclic compound which we are going to see the synthesis is the pyrrole. So from furan, industrially pyrrole is prepared by passing a mixture of furan and ammonia over alumina at 400 degrees Celsius. And here alumina is nothing but aluminium oxide. So as given by the definition, when furan is reacted with ammonia in presence of alumina, that is aluminium oxide, at 400 degrees Celsius, we will yield the pyrrole. There are other way of synthesizing pyrrole, but here we are taking only furan, which is most important for your semester exams also, and also in NET and CSIR examinations. So here we'll see the reactions of pyrrole. That is, the first reaction of pyrrole is diazolation. Pyrrole reacts with benzene diazonium chloride in acidic medium to give 2-phenyl azopyrrole. So as seen from the definition of the reaction, when pyrrole reacts with benzene diazonium chloride in presence of heat, we'll get 2-phenyl azopyrrole. The next reaction is Reimer-Teimer reaction. The pyrrole reacts with chloroform in presence of alcoholic potash to give 2-formyl pyrrole. So here alcoholic potash is nothing but potassium hydroxide, which is KOH. So from the explanation in words, we can draw the reaction as follows. When pyrrole reacts with chloroform in presence of alcoholic potash, that is KOH, we'll get 2-formyl pyrrole. So the group which is present here is called as formyl group, and since this is a pyrrole ring and which is at the second position, the formyl group is at the second position with respect to the nitrogen. This is 1, 2. So 2-formyl pyrrole is the product we have obtained. The next heterocyclic compound which we are going to deal is pyridine. So synthesis. So the synthesis of pyridine is achieved from acetylene. Industrially, pyridine is synthesized by passing a mixture of acetylene and HCN through red hot tube. So what is this red hot tube? Red hot tube, it is often made up of iron. The next heterocyclic compound which we are going to synthesize and see the reaction is of pyridine. So synthesis of pyridine from acetylene. Industrially, pyridine is synthesized by passing a mixture of acetylene and HCN through red hot tube. So what is this red hot tube? A red hot tube, it is often made up of iron squads heated to extreme temperature, which is typically around 400 to 600 degrees Celsius, a classical method used to induce the thermal cyclization and polymerization. So the red hot tube method is usually used in thermal cyclization and polymerization, which is nothing but formation of polymers, and it is actually a combination of many metals, usually of quartz and iron, which is heated to extreme temperature of 400 to 600, so that the bond formation which takes place at extreme temperatures and conditions will be more stable, and their boiling point, melting point will also be more. So, as seen from the definition of synthesis, when acetylene is made to react with the HCN in red hot tube, we'll yield the corresponding compound, that is pyridine. Now we are going to see the reaction of pyridine. First one is bromination. As the name itself suggests, bromination is nothing but addition of bromine to the pyridine ring. So pyridine reacts with bromine at a very high temperature to give 3-bromopyridine. So high temperature is required to break the bond of carbon and hydrogen present in the pyridine ring. As they are made in the red hot tube, obviously their melting point and boiling point will be more. So to break the bond of carbon and hydrogen, the temperature used for bromination is also high, that is of 300 degrees Celsius. So as the name itself suggests, bromination, and the reaction is given here. When pyridine reacts with bromine at very high temperature, 3-bromopyridine is obtained. Here we can see instead of one hydrogen atom, bromine has got attached or bonded to the carbon atom of the pyridine ring. The next reaction is a reaction with sodium amide, or also called as sodamide. When pyridine reacts with sodamide, it will give 2-aminopyridine. So it is a very simple reaction. Here we can see the addition of amine group to the pyridine ring. So pyridine will react with sodamide at 100 degrees Celsius to give us pyridine 2-amine. This question is usually asked for 2 marks in your semester examination, which is more important. They might also ask with the question, write the product when pyridine reacts with sodamide. So remembering the reaction and also their names is very important for your semester examination, and also in some of the competitive exams like UGC NET, CSIR, and also usually asked in JEE and GATE exams also. Now, the next heterocyclic compound which we are going to see is indole. So, first we'll see the synthesis of indole. When phenylhydrazine reacts with the pyruvic acid to form phenylhydrazone. On heating with the anhydrous zinc chloride, phenylhydrazone gives indole 2-carboxylic acid, and which undergoes decarboxylation to form the indole. So the reaction and the mechanism is represented here. When phenylhydrazine, it reacts with pyruvic acid, this is the pyruvic acid, and here removal of water molecule will take place, that is 1H from here, 1H from here, another H from here, and O from here. So this H2O will be removed and we'll get phenylhydrazone. When this phenylhydrazone is reacted with zinc chloride in presence of a heat, then removal of NH3 will take place, which results in the formation of indole 2-carboxylic acid. The carboxylic acid is present at the second position with respect to the N, and thus indole 2-carboxylic acid name is given. On heating the indole 2-carboxylic acid, decarboxylation takes place, and finally we'll get our desired product, that is indole. Next we'll see a reaction of indole with bromine or also acetic acid. Indole undergoes bromination at very low temperature in the presence of acetic acid at C3 position. So indole will react with bromine or undergoes bromination, which is nothing but the addition of bromine to the indole ring. in presence of acetic acid at 0 degree or at cold temperature to give 3-bromo-indole. So this is the simple reaction of how indole will undergo bromination. The next is reaction with chloroform or sodium hydroxide. So how does indole reacts with chloroform or and sodium hydroxide, and what is the product form? When indole reacts with chloroform in the presence of alkali to give aldehyde group at C3 position. In general, two products are obtained. The other one is 3-chloroquinoline. So when indole is reacted with chloroform in presence of sodium hydroxide, we yield two product. So one, the main product, which is indole 3 carbaldehyde. So here the aldehyde is placed at the C3 position. So this is the main product which we get, but along with this we get another product which is 3-chloroquinone. So these were the synthesis and reactions of indole. Now we'll see the synthesis and reactions of quinoline. So the quinoline synthesis using the Surcup synthesis. So this is a method or synthesis process which is used in the synthesis of quinoline. So here we'll take aniline which will react with the glycerol in presence of concentrated sulfuric acid and also nitrobenzene to yield quinoline. So this is a simple definition and also a simple reaction which is represented here. So when aniline reacts with glycerol in presence of concentrated sulfuric acid and nitrobenzene, it will yield quinoline. Now we'll see the mechanism which is involved in the synthesis of quinoline by Surcup method. So it is a two-step reaction. So first, when glycerol is reacted with concentrated sulfuric acid, removal of two water molecule takes place which leads to the formation of propa 1,2 diene-1-ol. So which can undergo tautomerization and leads to formation of propa 2-enol. So this propa 1,2 diene-1-ol or propa 2-enol will react with aniline. So the lone pair of electron which is present on the nitrogen are attracted by the carbon atom of the propa 1,2 diene-1-ol. So by reaction here double bond will get shifted and one bond from oxygen will also be removed, and thus the corresponding semi-cyclic compound is formed which undergoes hydrolysis in presence of concentrated sulfuric acid leads to the formation of the following compound. So this when undergoes oxidation and removal of water molecule takes place in presence of nitrobenzene which leads to the formation of quinoline. So this is the mechanism which is involved in synthesis of quinoline by Surcup synthesis. Now we'll see reaction of quinoline. Reaction with sodamide. When quinoline reacts with strong bases like sodamide in presence of liquid ammonia, it gives 2-amino-quinoline. This is a simple reaction. So when quinoline reacts with sodamide in presence of liquid ammonia, it gives us 2-amino-quinoline. And the next reaction is a reaction with the KMNO4. In presence of KMNO4, quinoline get oxidized by KMNO4 to pyridine 2,3 dicarboxylic acid, as potassium dichromate, that is KMNO4, is a very good oxidizing agent. It will make the quinoline undergo oxidation to form pyridine 2,3 dicarboxylic acid, which on decarboxylation gives the nicotinic acid. So here the reaction is given and we can see when quinoline reacts with KMNO4 at 337 Kelvin, formation of pyridine 2,3 dicarboxylic acid is formed, which on decarboxylation will yield as nicotinic acid. So the next reaction is nitration. Nitration is nothing but addition of nitrogen to the given compound. So the nitration of quinoline can be achieved as follows. When quinoline reacts in presence of concentrated sulfuric acid and concentrated nitric acid, we will get two products, that is 5-nitroquinoline and 8-nitroquinoline. As we know, the numbering starts with the nitrogen which is present in this ring 1, 2, 3, 4, 5, and similar here also 1, 2, 3, 4, 5, 6, 7, 8. Since the numbering system is given as follows, the name 5-nitroquinolane and 8-nitroquinolane are same. The next one is reaction with alkaline, that is with KMnO4 or sodium hydroxide. Since we know that KMnO4 is a very good oxidizing agent, the quinolane, so this structure is of isoquinolane, iso which is nothing but similar. So the position of nitrogen has changed, but the functioning and properties is similar to that of quinolane. Thus the name isoquinolane. So when this isoquinolane reacts with alkaline KMnO4, we'll get two corresponding product, that is phthalic acid and pyridine 4,5 dicarboxylic acid. So this was the synthesis and reactions which were involved in the quinolane. Now we'll see our last heterocyclic compound, that is pyrazole. Synthesis of pyrazole from hydrogen. When pyrimidine reacts with the hydrogen at 130 degrees Celsius, it gives us the pyrazole. So this is a simple reaction as mentioned. When pyrimidine reacts with hydrogen, that is NH2 at 130 degrees Celsius, we'll get our heterocyclic compound pyrazole. Some of the reactions of pyrazole are nitration. When pyrazole reacts in presence of concentrated nitric acid and sulfuric acid, it leads to the formation of 4-nitropyrazole. So as we know, nitration is nothing but the addition of nitrogen to the given compound, and thus when pyrazole is reacted in presence of concentrated nitric acid and concentrated sulfuric acid, it yields us 4-nitropyrazole. Next is bromination. When pyrazole reacts with NBS in presence of water and heat, it yields us 4-nitropyrazole. So nitration and bromination both can be asked in a single question to write how 4-nitropyrazole are obtained or how 4-bromopyrazole is obtained, each for 2 marks. The next one is when cinnamaldehyde is reacted with NH2OH, removal of water molecule will take place, which leads to the formation of corresponding product, which on reaction with the phosphorus oxide in presence of heat will yield as isoquinolane. So in this video, we have covered the definition of heterocyclic compounds and synthesis and reactions which are involved in some heterocyclic compounds such as furan, thiophene, pyrrole, pyridine, indole, quinolane and pyrazole. Hoping this video was very useful to you and it has helped you in your semester examination. Thank you for watching. See you all in my next video.